In this lesson, we are going to continue with Mathematics Paper 1 of 2016 internal. We'll begin from question 14. Now, the first question is given that universal set has elements A, B, C, D, E, F, G, and H. Then our A has elements A, B, C, D, and set B with elements B, C, D, E, F. Now the question is we are asked to list A union B complement. So now first let's find A union B, then we'll look at the complement later on. Now for us to find the A union B complement, we are trying to combine the elements of A with the elements of B and make one set. So the A union B elements will be A, B, C, D, D, E, F. So this is the union of A and B. Now from there we can go back and consider the complement. So the complement simply means that we need to exclude the elements of A union B from the universal set. So let's cancel. So from the A union B, we have A can be removed, B, C, D is there, F also is there. So we can see that our answer for A union B complement this will have G and H. So this is our final answer for the first part. Now let's move on to question B. Find the equation of the straight line passing through -4, 4 and is perpendicular to the straight line whose equation is y plus x over 7 is equal to 1. Now, so here we have x1 and y1. Now, for us to find the equation of a straight line, the formula is y minus y1 is equal to gradient, then open bracket x minus x1. Now, we can see that we have the x1 and the y1 coordinates. Now, our work is we need to find the gradient of this particular equation. Now we are going to use this given equation for us to find the gradient. So the equation is y plus x over 7 then is equal to 1. So our first step, we are going to move x over 7 to the other side. So the work is you make letter y the substitute of formula. So y is equal to 1. So since the x over 7 has a positive sign, so after shifting to the right side, the sign will change to minus x over 7. Now the gradient is just the coefficient of x. So the coefficient of x is -1 over 7. So -1 over 7 is our gradient. Now this is the gradient of the equation that we have been given, which is y plus x over 7. Now we are trying to find the gradient 2, since now the condition is the gradient that we are looking for is the one that is perpendicular to this equation. So what you have to do is, if you have gotten the gradient such as like this one where we have a fraction, so we just have to flip the fraction and change the sign. So what this means is, instead of 1 over 7, this will become 7 over 1, which is same as 7. Since 7 over 1 into 7 is 7, then the gradient 1 here is negative, then our gradient 2 is positive. So for you to find the gradient of a perpendicular line, the gradient given or calculated, the sign must change. Then also, if you have been given the fraction, you just have to flip the fraction where the denominator becomes the numerator and vice versa. So since now we have the gradient, we can now proceed. So we can say now y minus our y1, we can see we have 4, then 7 x x1 that is negative 4. So y minus 4 is equal to, so this 7 will multiply with x, then the second one by 4. So 7 times x is 7x. Now we can see that we have a negative multiplied by this negative. So our answer here, we are going to have a positive, then 7 times 4 is 28. Then from there, we are going to shift this negative 4 to the other side, giving us y is equal to 7x plus 28. Since the negative 4 will have a positive sign, so we're going to say 28 plus 4, that is 32. So this is the solution for part B. Now let's move on to question 15. Question 15 reads, the diagram below shows an equilateral triangle ABC. A is due north of B and C, and is parallel to BA. So now from the given question, we have been given a statement where we are dealing with an equilateral triangle. So the first property given to an equilateral triangle is it's a triangle with 3 sides that are equal. Then also what you have to know is each angle is equal to 60 degrees. So the angles are equal in an equilateral triangle. So here we have a 60, then also 60, and also here 60. Now what we are going to do is we need to extend. So we are going to draw an extension line here. So we indicate north. Also we need to extend here, and also we extend. Then from there, let's look at the first angle. We are looking at BCN. So the BCN is this angle. So this is our BCN. Now from the BCN, we already have the 60 degrees. So our work is we need to find this angle. If we find this angle, we can add plus the 60. Then we have the angle under consideration. So what we are going to do is we are going to use the principle of the alternate angle. So we can see that here we have a 60. So the angle here and the angle also here must be equal to. So since here we have a 60, even here we are going to get a 60. So BCN is equal to the 60 inside plus this exterior angle 60, which is equal to 120. So here we have 120 degrees. Now from there we can now proceed with the bearing of C from A. Now this bearing angle, number one, the direction whenever you are dealing with a bearing is clockwise, and also you need to know that what you have to put into consideration is where the bearing is coming from. So this bearing is coming from A, attaching the C. So let me try to redraw the diagram. So we have a structure like this. So our A is here, then our C is here. So this bearing is coming from the north of A. So this is where it is coming from. Then moving in a clockwise direction, touching the C. So this is the angle that we are solving. So this angle here is what we are looking for. Now we can see that inside here we have an angle of 60 degrees, and we know that a straight line, the straight line adds up to 180. So for us to find this angle, we are going to subtract 60 from 180, which is also giving us 120. So the answer for part B is also 120 degrees. Okay, now let's move on to question 16. Given that f of x is equal to 5x plus 4 over 5 and g of x is equal to x minus 1, find f of inverse. So we are looking at the inverse of the first function. So let's look at the first function. So whenever you are solving for the inverse of a function, you need to replace the f of x with y, Then from there, after you've done that, you need to make letter x the subject of the formula. So since on this side we have a fraction, we'll say over 1, then we can cross multiply. So 1 will multiply by 5x plus 4. So 5x plus 4 times 1 is equal to 5x plus 4. Then is equal to 5 times y is 5y. Now, since we are trying to make x the subject of the formula, any term that does not contain x should be shifted to the other side. So our positive 4 will be shifted to this side, leaving us 5x is equal to 5y minus 4. Now, for us to isolate x, we are going to divide here by 5, also here by 5, so that if we cancel, we have x is equal to 5y minus 4 over 5. So now we can see that we are done making letter x the subject of formula. So now where there is x here, we need to substitute with this expression where f of inverse raised to the power -1 is equal to, now where there is y, you need to replace with x, so this becomes 5x minus 4 divided by 5. So this is our first part. Now let's move on to part B. So part B, we have f of inverse of -2. So first we are going to write an expression for the inverse function. So the expression is f of inverse. We have found this expression here. So is 5x minus 4 divided by 5. Now the expression is now f of inverse -2. So what this means is we need to substitute x with -2. Then we can do the math. So 5 times -2 is -10 minus 4 over 5. -10 minus 5, so since we have same sign, we are going to add, so we get -14 over 5. So we can leave our answer like this, or we can divide 5 into -14 is -2, remainder 4 over 5. So this is our answer for part B. Now part C is, now we are trying to find the composite. So a composite function is where we combine two functions to make one function. So here we have an expression of f of g of x. So you can see that the first function is f. So begin with the first function, then open brackets, then the g of x, this g of x will be substituted into the x value of the first function, which is f of x. So the first step is we are going to rewrite the expression for the original f of x function, and the function is 5x plus 4 divided by 5. Now where there is x, we are going to substitute with the g of x function, which is x minus 1. So this becomes, so from there we are going to distribute our 5. So our 5 will multiply with x, the second one, with -1. So 5 times x is 5x. 5 times -1, that is -5 plus 4 divided by 5. So our final answer is 5x, -5 plus 4, that is -1 over 5. So this is our final answer for this problem. Okay, now we can move on to question 17. So evaluate. The first part is 5 raised to the power 0 plus 5 raised to the power 1. So we can now use one of the principles of indices. Any number or variable raised to the power 0 is equal to 1. So where there is 5, we have 1 plus then anything raised to the power 1 is equal to the same thing. So 5 raised to the power 1 is equal to 5. So 5 plus 1, our answer here is 6. Now let's move on to question B. In the answer space below is an incomplete simple program suitable for calculating and outputting the volume of a cylinder V given the base radius R and height H. Complete the program by filling in the blank spaces with the appropriate statements. So first we are going to write the formula for the volume of a cylinder. So volume of a cylinder V is equal to pi times the radius squared multiplied by height. Now since pi is a constant value, so a constant value is never considered to be the input. So in our case, the inputs are radius and the height. So these two values denote the inputs that we have. So let's now begin. So begin, enter. So the enter, we are going to enter radius. So whenever you are trying to indicate the enter, you need to put the information that is referring to as the input. So we enter the radius, then the other one is the height. Okay, so then from there, where there is this V, we need to write the formula. So it's pi multiplied by radius times another radius times the height. Then we have completed this incomplete pseudo code. Now let's move on. Let's look at question 18. So find, we have been given this elongated s, then we have 6x squared minus 5. So whenever you have this symbol s, we are trying to integrate. So this is the integral part of calculus. So the integration is just the opposite of differentiation. So what we are going to do is we need to add 1 to the power of our x. So this becomes 6x squared. So we add 1, then whatever we do to the top must be done also to the bottom. So over 2 plus 1 minus. Then here we can see that we have the constant number, which is a number. So whenever we have a constant number, you add an x to it. So this becomes 5x, then plus a constant c. Then let's simplify it. So we can see that here we are going to have 6x raised to the power 3 over 2 plus 1 is 3 minus 5x plus c. So we can divide 3 into 6 is 2x raised to the power 3 minus 5x plus c. So this is how we can integrate a problem like this one. Now we can move on to question B. The diagram below shows triangle PQR in which PQ is equal to 12 centimeters, QR 10 centimeters, and angle PQR is 150 degrees. Now the question is calculate the area of triangle PQR. So we are dealing with a non-right angle triangle, and the formula for a non-right angle triangle, the area is equal to half AB sin C. So this formula comes from the topic of trigonometry. So now let's see the letters that we have here. So we can see that the angle Q corresponds to this distance. So here we are going to have small letter q. Then here we are going to have small letter r. Then here we are going to have small letter p. So from the formula, we can see that the A and B represent the two distances that are making the angle. So in our case, it's P and R. So our formula can be written as half PR sin the angle Q. Okay, now let's do the math. So we have half. So distance P is 10 centimeters. Then distance R 12 centimeters. Sine 150. Now you can see that we do not have the calculator under paper 1, so we need to use the principles under special angles. Now if we go back to the special angle, sine 30 is 0.5 or half. So if we subtract 30 from 180, we are going to have 150. So sine 30 is equal to sine 150. So you need to have that in mind. So whenever you see sine 150 is same as 0.5 or 1 over 2. So now we can say we have half times 10 times 12 times, so sine 150 is half or 1 over 2. So let's now reduce. So we can now divide 2 here is 1, 2 into 10, that is, we have 5 centimeters, times 2 here is 1, 2 here is 6. So times 6 centimeters. So our final answer, 5 times 6 is 30 centimeter, multiplied by centimeter, we get our centimeter squared. So this is our area for this problem. Now let's move on to question 19. So in the diagram below, PR is the diameter of a circle with center O. Q and S are points on the circumference. The tangent to the circle at the point P meets QS produced a T. Angle PQR is equal to 26 and QPR is equal to 42 degrees. Now here we are going to use the circle theorem properties. So let's now begin. Let's look at the angle that we are solving. So the angle that we are finding is PRS. So let's look at the P. So this is our PRS. So the angle that we are solving here is this one. So for you to know the angle that you are solving, you just have to look at the middle letter. Then the other two letters will give you the direction or give you the angle, the actual angle that we are trying to find. So from the diagram we can let's say if we have this one. So if I have maybe a diagram like this one, where we have segments, 2 segments, so you can see that this angle and this angle, they are equal. So this property is the angle in a same segment are equal. So that is the property we are going to use for this one. So the angle here is equal to this angle. So this is 26 degrees. Okay, now let's look at the angle PRQ. So PRQ, this angle. So now let's also maybe try to have a picture. If we have a circle like this one, then we have a diameter. A diameter is a chord that cuts a circle into 2 halves. So we are going to have a semicircle. So the semicircle is the angle here is always equal to 90 degrees. So since we have been given this angle, which is 42 degrees, for us to find this angle here, we just have to subtract 42 into 90. So what this means is we are going to say for us to find angle PRQ is equal to 90 degrees minus 42 degrees. This will give us 48. So that is our answer, 48. So as long as you have the diameter there and you have been given this angle, for you to find this angle, just subtract the given angle there from 90 degrees. Then let's look at the PT Q. So PTQ, this angle here. Now let's go back to PR. So PR is a diameter. If PR is a diameter, then PO is a radius. So the radius PO meets the tangent TP at 90 degrees. So the angle here is equal to 90 degrees. So let's try to redraw this triangle here. We have a picture, so we have a triangle like this one. So this is the angle that we are solving. So here we have 26. So this is 26. Then here we have this 42 plus 90. So 42 plus 90, this is equal to 132. So for us to find this angle, we are going to find the sum of 132 and 26. Then we subtract that one from 180. Then we have angle T. So let's add 132 plus 26. So we can see that here we have 8, 5. So 132 plus 26 is equal to 158. So if we subtract 158 from 180, we have 22. So this is the angle that we have here, which is 22 degrees. Now, for you to fully understand and for this topic to make sense to you, please make sure you master the properties associated with second theorem. Okay, now let's move on to question 20. So it is given that W varies directly as the square of x and inversely as y. Write an expression for W in terms of x, y, and a constant k. Okay, so let's say we have W varies so directly as the square. So this language here, mathematics language, is also very important. So whenever you hear the term square, that letter must be squared. So the x should be squared. Then multiply by, we have the inverse of y. So the inverse is written as 1 over that particular letter. So 1 over y, since y is inversely. Then from there, we can now write our W. Where there is this symbol, we put equal sign. Immediately we put equal sign, we need to introduce the constant of variation, which is k. So k times x squared is kx squared over then y. So this is our first answer. We've written the expression according to the information. Now let's look at question B. If x is equal to -6 and y is equal to 12, w is equal to 15, find k. So let's begin by substituting. So where there is w, we put 15. K is what we are solving for. Now for x, we have -6 times another -6, since our x is squared. Then everything divided by y. Our y is 12. Now there are so many ways in which we can simplify this question. So you just have to find what works for you. So as for me, I like to do it like this. So I'll just say over 1. So what I'm going to do, I'm not going to find the actual answer, the product of 15 times 12. So what I'm going to do is I'll just leave everything like this. So I know that this negative times this negative will give us positive. So then I'll just write 6 times 6. I know it's 36, but I'll just write it as 6 multiplied by 6. Then is equal to 15 times 12. Now 12, I'm going to break 12 into two numbers in such a way that 1 should be equal to 6. So 12 is same as 6 times 2. Where so this is just one way of simplifying a question like this. So if you want, you can first multiply 12 times 15, it gives you the actual number, then you divide. But that one may give you difficulties in case it gives you a larger number and you're not using a calculator. So let's divide first. I'll remove 1 6 from here. Also we can divide by 6 here, so that when I cancel 1 6, I can see that I have 6, only 1 6 remaining. So 6 times k is 6k. So we get 6k. Then I can cancel this, giving me 15 multiplied by 2. So you can say over 6 over 6 is also same as 3 times 2. So that when I cancel this, I can cancel this one. So we can see that now it's very easy for us to divide 3 into 15. So 3 into 15 is 5. So okay is equal to 5. Now let's find the last one. Find the value of y when x is equal to 8 and w is equal to 20. So first let's write our expression. So what are we solving? We are solving for y. So w is equal to 20. Okay, we have it is 5 times our x is 8. So since it's squared, 8 times 8 over y. So over 1, let's cross multiply. So 20 times y is 20y. 1 times 5 times 8 times 8, that is just 5 times 8 times 8. So you can divide by 20, also here by 20. So let's break 20 into two numbers. So 20 can be broken as 5 times 4. So that I know that if I cancel this, so this 5 here will be cancelled, giving us y is equal to, so here we can see that now it's easy to divide 4 into one of these two 8. So 4 into 4 is 1, 4 into this is 2, 2 times 8, our final value is 16. Okay, now we can move on to question 21. On the xy plane below, the region R is unshaded. Write the 4 inequalities that define the region R. Okay, so you can begin with any of your choice of these inequalities. So let's number this. So consider this one to be the first one, the second one, then our third, then we have this one as our fourth inequality. Now first we'll begin with these, the ones that are touching only one axis. So let's begin with one. So you can see that this one, it is touching or cutting the x-axis at 2. So you put x, then you write the number 2. Then let's look at the two regions. So this one is less, then here we have a greater. So the shaded is the unwanted, then the unshaded is the region that we want. So here we can see that we want the greater one, so we are going to use the greater than or equal to symbol. So that is our first inequality. So let's look at the second inequality, this one. So you can see that this one now is cutting the y-axis, so it's y. Then it's cutting is between 2 and 4, so it's 3. Then let's look at the region of consideration. So the lower one is less, the upper is greater. So from the given, we can see that the less is shaded, the greater is unshaded, so we want the greater one. So we use greater than or equal to symbol. Let's move on to Roman number 3. I mean the third inequality. So here it is also cutting the y-axis. Then it's between 6 and 8, so that is 7. Now let's look at the region of consideration. The upper is greater. So you need to have this in mind. The upper is always greater, then the lower is less. So the shaded one is the greater. So the one that we want is less. So this time we are going to use the less than or equal to symbol. Then now let's look at the fourth one. So the fourth one, we can see that it's slanting. So the first thing that we need to do is we need to find the coordinate here and also the coordinate here. So the coordinate here, this point is 9, so let's say, so we have 9, the x, then the y is 3, is 9, 3. Then for this one, it's 5, 7. So we have x1, x2, y1, y2. So we are going to find the slope, which is the gradient. So the slope is equal to, so this is the formula. So y2, we can see that we have the 7 here, minus the y1 is 3, divided by x2 is 5, minus 9. So 7 minus 3 is 4, over 5 minus 9 is negative 4. Negative 4 into positive 4 is negative 1. So this is our gradient. Then after finding the gradient, we are going to apply the formula for the equation of the straight line. So this is the formula for the equation of the straight line. So now we can say y1 we have is 3. The slope is negative 1. Then our x1 is 9. So we are going to distribute negative 1 with everything inside the brackets. Negative 1 times x is negative x. Negative 1 times negative 9 is positive 9. From there, we have to move negative 3 to the other side. Y is equal to negative x plus 9 plus 3. Then y is equal to negative x plus 9 plus 3 is 12. Now the remaining part is removing the equal symbol and replace it with the inequality. So let's go back. So the upper is greater, then the lower is less. So now we can see that we want the less, so we are going to use the less, but the line, this line symbol is dotted, so we are just going to use the less than equal sign. We are not going to put the less than or equal. We are just going to use the less than symbol. So this is how we can answer a question like this one. Now let's move on to question 22. The first one, solve the equation. So the equation is x squared is equal to 3x. So this is a quadratic equation because the highest power is 2. So the first step here is we need to move 3x to this side so that we get a 0 here. So we have x squared minus 3x. So then is equal to 0. Then after you've done this, we need to factorize. So let's look at the common factor here is x. Then we divide x into x squared is x minus x into 3x is just 3 is equal to 0. So the first value here, x is equal to this 0. Then the other value will be x minus 3 is equal to 0. Then we're going to move this negative 3 to the other side, giving us positive 3. So positive 3 plus 0, that is 3. So these are the solutions for the first part. Now question B. The diagram below shows a sketch of the graph of y is equal to 3 minus 2x minus x squared passing through PQ and R. Find the equation of the axis of symmetry of the graph. So the axis of symmetry is a vertical line that passes through this point here. And typically, this axis of symmetry can be found by finding the x-coordinate of the turning point. So the turning point is this point here, where the parabola curve turns. So let's find this value. So the formula is x is equal to negative b over 2a. Now let's write this in a standard form. So the standard form, we begin with the one with the squared, so negative x squared minus 2x plus 3 is equal to y, or we can just say is equal to 0. So here we have a, b, c. So the coefficient of x squared is a, and the coefficient of x is just b. Then we have the constant c. So let's do the math. So where there is b, the value of b is negative 2. The value of a is negative 1. So negative times negative 2 is positive 2 over 2 times negative 1 is negative 2. Then negative 2 into positive 2 is negative 1. Now, you need to take note of this point. This value is the equation of the axis of symmetry, and also it is the coordinate of the turning point. So for the other part, which is part 2, Roman number 2, we are trying to find the coordinates of the turning point of the equation. So this axis of symmetry, or the x-coordinate of the turning point, can also be used to find the y-coordinate of the turning point. So let's write so since we have the x-coordinate of the turning point, where there is x, we are going to substitute with negative 1. So let's simplify our answer. So negative 2 times negative 1 is positive 2, minus negative 1 times negative 1, that's positive 1. So negative times 1 is negative 1. 2 plus 3 is 5, minus 1 is 4. So the coordinates of the turning point is negative 1, 4. And it's making sense. We can see that this turning point, if we draw this line, it's touching on the negative part of the x-axis. That's why our x-coordinate is here is negative. Then for the y, it's positive. We can see that if we move this, we can have a value of 4. So the axis of symmetry is negative 1. Then the coordinates of the turning point is negative 1, positive 4. Now let's look at the question 23, which is the last one. The diagram below is the speed-time graph of a particle. The particle accelerates uniformly from a speed of v to a speed of 5 meters in 20 seconds. Okay, so now let's look at, we have a speed-time graph. So where we have the speed in the y-axis and time in the x-axis. So we can see that here, this is our initial point, because it's where the line originated from. Then this point is our final. So the final is 5v. The initial is just v. So the first question is, find an expression in terms of v for the acceleration. So let's write the formula for the acceleration. So acceleration is equal to final velocity minus initial divided by t. So acceleration is equal to final velocity is here 5v, minus initial is just v, over the time from this point up to here is 20. So we have A is equal to 5v minus v. These are like terms, so we can subtract, give us 4v over 20. Let's reduce. 4 into 4 is 1 over 4 into 20, that is 5. So now let's make v the substitute formula, since we are finding an expression in terms of v. So you can see 1 times I times v, that is just v. Then 5 times a is 5a. So that is an expression. So we have an expression like this one. Now let's look at so we can take it at this point, or we can just use this point. Now the distance traveled by the object from 0 seconds to 20 seconds is 80 meters. Find the value of b. So let's find the value of v. Now if we were to rotate this diagram, we can say that we have a trapezium where this value is a b. So we have the b value, then we have the a here, then this one will be considered to be our height. So we are saying if we are to draw it like this, this is the picture. So we have the b. Now the distance for a trapezium is, distance is equal to half a plus c b multiplied by height. So the distance is 80, half. So the value of a, so from here to here is v plus c. The value of b is 5v. Then the height is 20. So I can reduce. So we can say 2 here is 1, 2 here is 10. Then in brackets we can add, since they are like terms, so v plus 5v is 6v multiplied by 10. So instead of multiplying 10 times 6, then we divide by 60 both sides. We can just go direct. Let's divide by 10. So we can divide by 10, also we can divide by 10, so that if I cancel, I have 6v is equal to 10 into 80 is 8. So you divide by 6 and also here by 6. So v is equal to, so you can reduce 2 into 8 is 4, 2 into 6 is 3. So this is the actual value of v. So at this point, there is a value of 4 over 3. Now let's find our final velocity. So our final velocity is 5v, and we have calculated the value of v, so we can substitute where there is v with this. So it's 4 over 3. So 5 times 4 is 20 over 3. So the final velocity or speed is 20 over 3 as now the actual number. Now after we have done this, let's look at find the speed at t is equal to 15. Okay, let me first get rid of this. Okay, so now let's see. Okay, so let's say we have this is where our 15 seconds here. We are just making an approximation. So we want to find what is the speed at this point. So we are trying to find the value somewhere here. So now what we are going to do is, the first step that I'm going to do is, I'm going to find the acceleration, since we have the final velocity and the initial in terms of the actual numbers. So let's look at the acceleration now. So acceleration is equal to final minus u over t. So the final velocity is 20 over 3 minus the initial is 4 over 3 everything divided by 20. So no need of finding the common denominator, we already have this. So 20 minus 4 is 16 over 3, then divided by 20. So 16 over 3. Now this division, the reason why I've written this division as now the actual symbol. Now after doing this, we can now change it to multiplication. Then we know that we are going to, if this is 20 over 1, this becomes as 1 over 20, so that I can reduce this. This is same as 4 times 4 over 3 times 1 over 5 times 4. So I can cancel the 4 here and also the 4 there. So now I can see that the actual acceleration is 4 times 1 is 4 over 3 times 5 is 15 meters per second squared. So this is the acceleration of this line, this straight line. Now since the acceleration the line is a straight line, the acceleration is constant. So what you are going to do is, since we have the acceleration, so I'll just consider these 2 points, this point and this point. So we are going to now apply the new formula for the acceleration. So acceleration is equal to final minus initial divided by t. So where there is acceleration, so this, what this means is, since the initial velocity here I have it, so it's like now we are finding the final velocity between this point and this point. So the acceleration is 4 over 15, the one that we have calculated. The final velocity is what we are solving, so v minus the initial is 4 over 3 over the time now we use 15, so over 15. So here we are going to cross multiply. So 15 we multiply with v minus 4 over this one. Then here we have 15 we multiply by this 4. So instead of multiplying 15 by everything in the brackets, first I'm going to divide by 15 here, also by 15, since I know that this and this will cancel. So this and this and this cancels, where we have v is equal to 4 over 3. Then here we have 4. Then from there we are going to move this negative 4 over 3 to the other side, giving us v is equal to 4 plus 4 over 3 over 1. So let's find the lowest common denominator is 3. 1 into 3, 3 times 4, 12, plus 3 into 3, 1 times 4, that is just 4. So our v is equal to 16 over 3. So this is our value at, so this is the speed of this particle when the time was 15 seconds, and it's making sense since the value here is 4 over 3. Then here this point is between the final is 20 over 3, so here it's making sense if we have 16 over 3. So this is how we can find the solution to this question. So that's it for this video. So asking for those that have not yet subscribed, please do so. Share the video. Let's this channel grow, so help me to share it with friends and family. So thanks for watching.